Select the major product of the following reaction. So we can see that we are starting with an alcohol, and specifically this is a secondary alcohol. And so we say that because here's our alcohol carbon, and we can see that it has 2 bonds to other carbons, so that makes it a secondary alcohol. And what we're reacting this with is hydrochloric acid combined with zinc chloride. So this is also known as Lucas reagent. And so what the role of that zinc chloride is the zinc chloride is an additional catalyst. And you tend to see this additional zinc chloride catalyst only with HCl, and that's because the chloride ion is not as nucleophilic. It's smaller, so it's not as nucleophilic than, say, bromide or iodide. All right, and so this is really only truly important in a reaction where the nucleophile is involved in the rate determining step. So this is really only important for SN2 reactions. So we'll say it's really important. You might still see it for an SM1 reaction, and this reaction is actually going to be an SM1 reaction because you've got a secondary alkyl halide and a hydrohalic acid. This is going to be SN1. Okay, so even though that zinc chloride isn't strictly necessary, I wanted to include it in this example just so we're familiar with this term Lucas reagent, which is the hydrochloric acid and the zinc chloride. So here's how the zinc chloride acts. So it is an additional catalyst, right? So we've got lone pairs of electrons on that oxygen, and your zinc is a metal, right? So it is electron poor, right? So what can happen is your alcohol can attack your zinc chloride and then kick off one of those chloride ions. And so this is going to give you, right? So we have formed a bond between the oxygen and the zinc, and then we still have one chloride on there, and we have a positive charge on that oxygen. So what we've done is we've made this into a good leaving group, and then this chloride ion that we liberated here, right, is still going to be in solution, but before that attacks, this good leaving group is going to leave, okay, because this is an SM1 reaction. So here we're getting it set up for the SN1, and right here is the first actual SM1 step where your leaving group leaves, which is going to give you a carbocation. So there is the carbocation. So our chloride ion could just attack this carbocation, but before we just assume that, we always want to look carefully at a carbocation and see if it can rearrange. So we should notice that we started with a secondary carbon, right? So this is, sorry, let me use the consistent color. So there's the carbon I'm looking at, 2 bonds to carbon. This is a secondary carbocation. And we know that tertiary carbocations are more stable. So hopefully we can see that we got this tertiary center next door. It's got a hydrogen on there. So if we have this 1,2 hydride shift, we can get to a tertiary carbocation. So here is that tertiary carbocation. So now this is as stable as it can get. There's no other way to make this particular system more stable than that tertiary cation. So now we have a chloride that we liberated here that can act as a nucleophile. So we have a chloride ion in solution, and this can act as a nucleophile and add to that carbocation. So this carbocation is flat, and so the chloride can attack from either side. If this were going to be a chiral center, we would see that we would form both enantiomers. This is not going to be a chiral center though because of the symmetry around the ring. So we're just going to form one product, and that product will be this structure here, C.